If you think back to adding fractions, we always needed to have a common denominator. So if we had numbers like 2/5 plus 1/5, what we would do is if the denominators were the same, we were allowed to add the fractions. We keep the denominator the same and then just add the tops. Same was true for subtraction. You need a common denominator, keep the bottom the same, and then add or subtract, and then subtract the tops. So when we extend our fraction work into rational expressions like this, if we ever get into a position where we need to add or subtract expressions that have variables in them, we still need to follow the same idea. If we have a common denominator, it's pretty easy. So let's take a look at what this looks like. It's kind of strange looking, so when you see it for the first time. So here in this example, notice that in number 1, we have an x minus 3 in the denominator and an x minus 3 in the denominator. That's great. So what that means is that we want to keep the denominator the same. So my denominator is still going to be x minus 3. And then on the top, I'm going to subtract just what the tops are, because there's a subtraction in between there. So what I'm going to have is 8x minus 5x on the top. Now, at this point, we want to try to see, are there any things that we can do to simplify? We can actually do 8x minus 5x, which is great. They're like terms, and we can combine those, and we'll get 3x on top. On the bottom, we have x minus 3. So bottom stays the same. 8x minus 5x gives me 3x on the top. And at this point, you need to check to see if your answer is fully simplified. And in this case, it is. Notice that the 3 here is next to a subtraction, so we can't cancel this 3 unless we cross out all of x minus 3. And there's no plus or minus or anything like that on the top, so nothing is available for us to be able to divide out. So that would be your final solution in this case. In problem number 2, same sort of thing. In this case, notice we're pretty lucky. We have a common denominator. It's a pretty big one, but that's okay. So what that means is we keep the denominator the same. It's still x squared plus 5x plus 6. But then I need to add everything that's in the numerator. So I had x squared minus 15x plus 12x minus 10. So I had this part plus this part. So I can just write that expression out right here. Now I need to see if I can simplify this. First of all, notice that there are some like terms on the top. We can do that minus 15x plus 12x to get a minus 3x on top. And now I have x squared minus 3x minus 10 in the numerator and x squared plus 5x plus 6 in the denominator. Sounds great. Again, I'd like to make sure this is completely simplified, so we need to make sure there's no common factors that we could divide out. In order to do that, though, we're going to need to actually factor these expressions. On the top, we need to factor x squared minus 3x minus 10. So we're going to try breaking that down into 2 sets of parentheses. We need things that multiply to get x squared, so x times x, and then things that multiply to get negative 10, and we want our middle terms to end up being negative 3x. Now, in this case, negative 5 times a positive 2 will get me a negative 10, and the negative 5x plus 2x will get me the negative 3x in the middle that I need. So that expression works for the top. Now I need to simplify the denominator, so let's do that. For the denominator, I had x squared plus 5x plus 6. I want to do 2 sets of parentheses there because there's no greatest common factor. X times x will get me an x squared. 2 times 3 will give me 6, and then double check and notice that you get 2x plus 3x gives me a positive 5x in the middle. So after factoring my expression, I now have this. X minus 5 times x plus 2 on the top, and x plus 2 times x plus 3 on the bottom. At this point, it's real easy to see that we do have a common factor we can divide out. The x plus 2 can divide out from the top and the bottom, and I'm left with my final, most simplified answer of x minus 5 divided by x plus 3.